All right, good morning, everybody. It's Mr. Lau once again. Hello, welcome back. All right. So, Science 20, here we go, Monday. All right, so we're back into organic chemistry. Last week, we got introduced to what organic chemistry is and also how to name and draw basic alkanes. And as a reminder, alkanes is a general term we use to talk about organic compounds that only have single bonds in between the carbons. An example of an alkane is right over here, an ethane. And as a review, the carbons always have to have 1, 2, 3, 4 bonds around it. 1, 2, 3, 4 bonds around it, okay? Now that is going to be ethane. Now what happens if, by the way, this is on page 164 of your notes, and if you want to take a look at your data book, turn to page 9. That's going to be a really good, helpful page for you there. Now, what happens if in our organic compound here, instead of only having single bonds in between the carbons, we have double bonds. Double bonds are basically a way for the carbons to share more than just one electron with each other. They can form double bonds in certain situations if necessary. Now, how do we name this? Okay, well, number one, we know that we have how many carbons are in this compound? We have 1 and 2. If you take a look at page 9 of the data book, as well as just remembering from last week, what kind of prefix do we use for 2 carbons? We would use F, okay? So we know that this organic compound is going to start with F, like methane has 1 carbon and ethane has 2 carbons. What happens when we have a double bond in between the carbons then? Well, it would no longer be called ethane because the single bond would tell us that we need an ANE ending. If we have a double bond though, that would actually mean we have a ENE ending. So this would be called ethene. Again, the F prefix for the 2 carbons and the ene suffix or the ending for the fact that we have a double bond in between the carbons. Now what about this one over here? Well, it doesn't have a single, it doesn't have a double, it has a triple bond, as you can see by the 3 lines in between the carbons there. How would we name this molecule? So again, we know that we have 2 carbons. Again, this would be called F as the prefix. What about the suffix? Specifically, class, when we are using triple bonds in between the carbons, this would be called Fi with a YNE ending. And class, these are going to be the types of molecules that we're going to be looking at today. They're going to be called the alkenes and the alkynes. And what does that mean? The alkenes, we have double bonds between the carbon atoms. And what about the alkynes? The alkynes mean we have triple bonds between the carbon atoms there. So if you, class, if you had a good understanding of the alkanes from last week, alkenes and alkynes should actually be easy to at least grasp for the first time. There's going to be a few small little tricks that we're going to have to pay attention to, okay? But besides that, I have full confidence that you're going to be able to understand this, okay? And as a reminder, why are we learning about the naming systems for alkenes, alkynes, as well as how to draw them? Because becoming an amateur organic chemist and understanding the reactions later on that we're going to be going into and how alkenes, alkynes, and alkanes are so important, we have to be able to understand how do we even talk about them to one another. All right, so let's get started with the next part of the video. All right, class, so for this next part, we're going to be discussing how do you draw, and we're also going to talk about a little bit about the naming. How do you draw and name alkenes and alkynes, okay? So they actually have very, very similar rules to each other, so I'm going to be talking about them both pretty much at the same time. So how do we draw ethene? And now we already did this actually before, but as a review, when we have the name, we got to sort of separate the name into the different parts. When we have the F prefix over here, we are talking about 2 carbons. And you should remember that from last week, or you can also take a look at page 9 of the data book. Okay, so we have 2 carbons, and the ene suffix tells us we have double bonds. Or a double bond in between the carbons, okay? So if we were to draw that out, we got 2 carbons over here. Okay, and we also know that we have double bonds. We need to be putting it like that. And of course, afterwards you have to draw the other hydrogens that we know that make up organic compounds, because these carbons need 4 bonds. If they have 2 over here, that means they need 2 more, and those 2 other ones are typically going to be connected to hydrogens. Okay? So that's how I analyze the name over there. Now there's going to be some tricky and funny things that happen, okay? So let's take a look at another example. Let's do something called, well, how about let's do this one. How would we name, or sorry, draw hexene? How would we draw hexene? Okay? Now, you should, again, taking a look at page 9 of the data book, what does the hex prefix mean? Hex means we should have 6 carbons. So we have 6 carbons. Okay? We have a meth, eth, pro, bute, methane, ethane, propane, butane, pentane, hexane, or hexene in this case. We have 6 carbons, and what does the ene tell me that we have? Well, we have double bonds. 100%. Now, how would we draw this? So, of course, let's go ahead and start with the basic premise of the fact that we have 6 carbons, okay? And let's go like this. Let's go like 1, 2, 3, 4, 5, and 6. All right, class. 6 carbons. Now we need to put the double bond somewhere. Class, where are we going to put the double bond? Could we put it over here? Well, why not, right? We could put it here, okay? That'd be hexene. But we could put it over here, and that would be hexene. Because hexene is just telling you I have 6 carbons with a double bond. I could also put it over here. Hexene. Class, this, I sort of tricked you because hexene is actually not a proper name for what it could be. I'm going to quickly show you in some examples you might see in the data book, okay? We're going to go like this. What we would normally see, actually, instead of just hexene, we would see hex, and we're like this, 1 ene in the middle of the name. Now you might be thinking, Mr. Lau, that looks like nonsense to me. What is hex 1 ene? So again, as a reminder, what does hex mean? We got 6 carbons, okay? And what does the ene ending stand for? We have double bonds. Okay. Now, we only added 1 extra little thing in here, okay? What does the 1 in the middle of the hexene name mean? The 1 tells me which carbon atom the double bond starts at. So you can actually sort of read this from left to right across, and I'm sorry if I didn't really write this in very legible writing, but I'm just going to read it out to you. Hex 1e, we have 6 carbons. The 1 in between tells you which carbon atom the double bond starts at. And I'm going to show you that right here, okay? So imagine that we have our 6 carbon, and we're just going to number them from left to right, okay? We got 1, 2, 3, 4, 5, and 6 carbons. And we can number them like that. Numbering the carbons is going to be very important because that tells us where the double bond is, as well as from last week, it told us on which carbon certain functional groups or branches are going to come off of. Very similar reason why we have the number right over here. So we got the double bond. Where are we going to put the double bond? On the first carbon. Where's my first carbon? Right over here. So it starts here and goes like that. Class, that's it. This is hex 1e. How do I know that? Hex 1, 2, 3, 4, 5, 6 carbons. 1 on the first carbon. We have the ene, the double bond right there. And that's it. Of course, we would have to then Also, put the other hydrogens. For this one, we already have 2 bonds. We have 1, 2 hydrogens. This one has 3 bonds. We have 1 more hydrogen. This one has 2 bonds. We need 2 more hydrogens. And I'm just going to draw lines to represent the hydrogens because we don't really have too much time. So I'm not going to bother drawing the hydrogens. But if I just have these blank lines here, imagine that the hydrogens are sort of there, okay? So that's going to be hex 1-ene. Now, what if we were to juxtapose this with hex 2-ene? What if we did hex 2-ene over here? What would hex 2-ene look like? Well, it would look incredibly similar to this. We have 1, 2, 3, 4, 5, 6 carbons like that, okay? That's what the hex means. And if we were to number these carbons, 1, 2, 3, 4, 5, 6, okay? Now remember, the 2 tells us which carbon atom the double bond starts at, okay? It's not where it ends, okay? So keep that in mind. Hex 2-ene. 2-ene, ene means double bond. We need to put a double bond where? On the second carbon. We start from here and we go that way because that's where it starts. If I take a look at this, it starts at 1 and we count from 1, 2, 3, 4. We don't count from 2, 1, 3, 2, 4, 3, etc. That would make no sense. So this is hex 2-ene, hex 6 carbons, 2 on the second carbon. We have the ene double bond there. So these two, even though they look very, very similar, they're actually very different, okay? Because the double bond is at a completely separate area, and later on in your organic chemistry career, you're gonna notice that, oh, where the double bond is makes a big difference. And of course, hex 3-ene, we can even do it like here. If I had hex 3-ene, oh, where would that be? That would go like there, on the third carbon. One quick little trick I'm going to show you is, does hex, I'm just going to like this in hard quotations, does hex 4-ene exist? Well, it sort of does, but not really, because I'm going to tell you why. You might already notice this, but hex 4-ene, oh, where would the double bond be in this case? Well, the double bond would be on the fourth carbon, starts from there, goes that way. Now class, if you remember from last week, remember that rule about, oh, we always want to number things so that they're in the lowest number possible? Is this really the lowest number possible to count the carbons? Well, check it out. 1, 2, 3, 4, 5, 6. Okay, double bond on the fourth carbon. What if we were to do this? What if instead of counting from left to right, we count from right to left? If we had 1, 2, 3, 4, 5, 6, like that. Okay, well, if we do it like that, the molecule is the same. And would it really be hex 4-ene anymore? No, it won't. Because which bond is this on? It doesn't start from number 1, it starts from number 2. So hex 4-ene is the same as hex 2-ene. And do we want the lower number? Heck yes, we do. So that's hex-ene, hex 1-ene, hex 2-ene, hex 3-ene. Does hex 4-ene actually exist? No, it doesn't, because hex 4-ene is just hex 2-ene just like flipped, right? So, gotta watch out for some of those rules there, okay? So, in a bit, we're gonna be discussing the ines. Okay, so I sort of lied to you. We're not gonna discuss the ines just yet because we've got to cover one quick little thing. Okay, we have propene and but1-ene. Why do we have, for butene, how can we have the 1 here, but I don't bother putting any numbers for propene or even ethene? So I'm just going to draw you out the example, okay? So methane, ethane, propane. We have propene, we have 3 carbons. We have a 1, a 2, and 3. Now we only have 2 places to put the double bond because it's an ene. It's going to put it right there, okay? Now class, this is the exact same as this. They're just flipped, or you can just like take this and turn it around. They are the exact same. This propene is going to be the same molecule no matter what. Now what about but1-ene? Well, but1-ene, methane, ethane, propane, butane, 4 carbons. We got 1, 2, 3, and 4. Okay, where am I going to put the double bond? On the first carbon, right over here, okay? This, okay, is a different molecule than this, but2ene. 1, 2, 3, 4, 1, 2, there. Class, listen to my words very carefully. For propene, the double bond, it doesn't matter where the double bond goes for propene, it is the exact same molecule. So that means we don't need to bother putting a number in the middle of it. If the double bond goes on the first carbon, or if the double bond starts at the second carbon, they are the exact same molecule, except flipped. For butene, it does matter where the double bond goes. But1ene, if the double bond is on the first carbon, is a very different molecule than but2ene. This flipped around, still but2ene. But1ene, there's no way you could flip but1ene to make it but2ene. They would be different molecules every single time. So that is why propene, as well as ethene, there is no number in between the first part and the second part of the name, because no matter what, it's going to be the same molecule. For butene and then the other ones after that, it does matter. So that's why we need the number there. All right, now let's get into ions. All right, so we're going to be comparing alkenes and alkynes now. Okay, so hex-2ene. How would I draw hex-2ene? Hex gives me 6 carbons. Okay, so 1, 2, 3, 4, 5, 6. 2ene tells me ene, I have a double bond on the second carbon, just like that. What about hex-2-ine? Hex-2-ine is going to look like this. 1, 2, 3, 4, 5, 6 carbons like that. That's the hex part of the name. 2-ine, all right. Ine, from the beginning of the video, you should remember that ine means we have a triple bond. Where? On the second carbon, starting from the second carbon. 1, 2, there, like this, and 1, 2, 3. 3 bonds like that. And class, they're actually very similar, okay? They still use the number system in between there, okay? And that's actually it, okay? So, to do that, okay, we just have the ine, that just tells us we have a triple bond, and that's really the only difference. Well, I didn't really have much to say about that. Oh, let's do a harder example and how we reconcile the numbers here with the numbers that we might have in the branches. All right, so that's going to be the next part of the video. Okay, class, for this next little example, I'm going to address one small little thing that some students have trouble with. Okay, so we have 2 different names, and they're actually referring to the exact same molecule. Should the name of this molecule be 4-methyl pent-2-ine or 2-methyl pent-3-ine? So as you notice, okay, class, we still have that numbering system from before attached with the branches that we learned about last week. What kind of branch do we have on pentyne over here? We have a methyl branch, meth referring to CH4 as a branch, and the il telling us that it's a branch. Okay, so let's try to draw this out using either one of these, okay? So where both of them are telling me that I have, right over here, pent means 5 carbons. So let's go ahead and do that. We have 1, 2, 3, 4, and 5 carbons like that, okay? Now, both of these names tell me that I have a methyl branch, okay? Which one is it going to be on? Well, let's try to use this one and see how we can reconcile this, okay? So, we have 4-methyl, okay? So if this was 1, 2, 3, 4, 5, oh, well, 4-methyl, that means on the 4th carbon, I have a methyl branch. We're just going to go like this, CH4, just like that. So we got the 4-methyl part, we got the pent part, now we need the, we need the 2-ine part. Okay, well, what does the ine tell me? Ine tells me that I have a triple bond on the 2nd carbon. So let's go ahead and do that right now. 1, 1st carbon, 2nd carbon right here, ine, triple bond, like that. All right, so we just drew 4-methyl-pent-2-ine, and I didn't bother writing the hydrogens, but imagine that they are there. Now, problem, how come I use this name and not this name? This name, wouldn't this also make sense? Because if we take a look at over here, 2, this 2 is a lower number than that 4. Didn't you teach us last week that we need the lowest number for the branches? Didn't you teach us that last week? Yes, I did, class. Yes, I did. Problem. When we have these double or triple bonds for these alkenes or alkynes, okay? And we can even take a look. Is this a valid, quote-unquote, valid name for this molecule over here? Couldn't I just do this? Couldn't I number it the other way and give this carbon the name of the second carbon like this? 2, 3, 4, 5, like that. Couldn't I do that? Because then that would give this branch the lowest number for the branch of the methyl. Well, yeah, I mean, I could do that. We have a slight problem because by having this 3 for the triple bond there, this 3 is a lower number than that 2 over here. Pent-3-ine is not real because pent-2-ine gains priority going the other way. In other words, and I'm going to write this over here, okay? And I'm going to use red over here, okay? I'm just going to go like dots over here. We're going to go like dots over here. The lowest number for the ene or ine carbon is more important. Okay? So take a look at these two names, okay? We have 2-methyl-pent-3-ine and we have 4-methyl-pent-2-ine. Which one is correct? It's going to be this one. Why? When we take a look at the number that we use for the carbon for the ine ending or the triple bond, this number is more important and we need it to be the lowest one because it's more important than the number we use for the branch. Why? Class, this is the parent chain. The parent chain takes priority over the branches. Why would we want to give the branch the lowest number and give the parent branch, the basic foundation of the molecule, the higher number? That would make no sense, okay? So even though, oh yeah, we have a lower number with 2-methyl-pent-3-ine for the branch, 2 is lower than 4, problem, the 3 part of the pent-3-ine is a bigger number than the 2 over here. Why is that a problem? We need the lowest number for the ene or the ine ending part because it's more important. Okay? So that's why this name would actually be incorrect and this name would be, and that's how we would get the drawing for that molecule over there. So I actually sort of talked about naming and drawing at the exact same time over there. So it might have been a little bit confusing, but I just want you to understand this number, when we have alkenes and alkynes, having the lowest number right here is way more important than having a lower number for the branches. Okay, so keep that in mind. All right, let's take a look at how to draw. Name, sorry. Okay, class, so this example is not in your notes. I literally just came up with it on the fly because the one I was wanting to do was actually the one we just did. So we're just going to do this one. Okay, how do we name this molecule? Okay, and as a reminder, I'm not bothering to draw the hydrogens because we don't have time for that. But just imagine that they're there because they have to be there. Okay, so let's start off with first thing is we find the longest carbon chain for the parent chain. Okay, so let's take a look. Okay, we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Not going to do that. 1, 2, 3. Not going to do that. 1, 2, 3, 4, 5, 6. Okay, so after looking at every single possible combination, we have 6 carbons. Okay. What does that mean for the parent chain? Well, we are going to use the prefix hex because it has 6 carbons, okay? So 6 carbons, here we go. So we're going to name this hex for this part because we have 6 carbons for the parent chain. So 6 carbons for the parent chain. Okay, what's next? Class, is this an alkane, alkene, or an alkyne? Well, take a look. Single bond, that's good. Oh, wait a minute. We have a double bond over here. That means I need to have an ene ending because we have a double bond. Now, you might have remembered from earlier on in the lesson, we can't just call this hexene because for specifically molecules larger than propene that start out like, butene, pentene, hexene, okay? For these kind of molecules, we need a number in the middle between the hex and the ene part to tell us which carbon does this molecule have the double bond. All right, so let's, I'm going to show you the wrong way first and then the right way next, okay? So let's just imagine for a second that we numbered the longest carbon chain this way. 1, 2, 3, 4, 5, 6. Now you might be thinking to yourself, Mr. Lau, you're an idiot. I already know what the problem is. You'd be right, okay? If we go from right to left, what number would go over here? Oh, it'd be like, 1, 2, 3, 4. Oh, the double bond starts at the 4th carbon. So this would be hex 4ene. Incorrect, because this is not the lowest possible number. Why? We can just do this. Instead of going from the right to left, we can number the carbons left to right. We can go like this. 1, 2, 3, 4, 5, 6. If we do that, are we going to say it's hex 4ene? Oh, heck no, we're not going to do that. We're going to go like this. 1, 2, double bond starts at the 2nd carbon. This would not be hex 4ene. This would be hex 2ene. Perfect. All right, we're done. No, we're not. We still have to put in the fact that we have 2 of these branches on the 5th carbon, okay? So, first of all, what are these branches? Okay, these are single carbon branches. CH4, a single carbon branch. CH4, a single carbon branch. How do we name the branches? Okay, so we know 100%, okay, that if we have branches over here, they're going to end with YL. And what kind of branch are they? They're a single carbon branches. So it's going to be meth. Il, okay? So the il part means it's a branch, okay? And the meth part means it has 1 carbon. So we have a 1 carbon branch off of hex 2ene. Problem, methyl just means we have 1 branch. How many branches do we have? Okay, we have 2 branches there, okay? So we have a dimethyl, okay, good. The di referring to the fact that we have 2 branches, or 2 of these same branches over here, 2 1 carbon branches, dimethyl, okay? Are we done? No, we're not, because if we just say dimethyl hex 2ene, these branches could be anywhere, on any carbon. They are specifically on the 5th carbon. So, what do we got to do about that? I run out of colors because I've used green, black, blue, and red already, so I'm just going to have to double up on one. Let's just use red again. So, on which carbon is the dimethyl on? The 2 methyl branches? It is on the 5th carbon. So we have a methyl group branch on the 5th carbon, and we have another methyl group on the 5th carbon like that. So this would be 5,5-dimethyl hex 2ene. So class, when you just take a look at this by itself, you're thinking this looks very complicated, but go back and figure out or re-watch, how did I start? I started with the fact that it's a hex, 6 carbon parent chain. I figured out that it's an ene with a double bond. I figured out where that double bond is using the lowest number possible. And then at the end, I worked backwards like that. Class, if you start doing the naming in parts, in small little steps like that, it's going to be a lot more simple and you're going to be able to understand what's going on a lot better. If you just try to start from here and go from left to right, you're actually going to have a lot of trouble. When you name organic compounds, you actually want to start at the end part, the parent chain, and then figure out the branches. Give that one a shot, okay? Then we're going to do one more example. All right, class, so this is going to be our last example together here, okay? So we have this molecule, and again, you can imagine that the hydrogens are there, okay? I just didn't bother drawing them at all, okay? And then this one, good, this one, we need another one there, and okay. Now, class, first things first, find the longest carbon chain, okay? If I was to do this, I would have two options. Oh, 1, 2, 3, 4, 5. That's a pent something or other, okay? Are we going to start this name in the parent chain with pent or hex? Class, I could do it like that, pent, okay? And then 1, 2, 3, 4, 5. I could be like that. Oh, you know, pent, whatever, pentyne, pentene, whatever. And then I can say, oh, I have 1 methyl branch, 2 methyl branches, and 3 methyl branches. Oh, this will be like a trimethylpentene or whatever. Class, even if, pay attention to what I'm saying right now. Even if there is a bend over here and you might think, oh, this looks like a methyl branch, class, you are not counting correctly. No matter if there is a bend or not, always try to find the longest carbon chain, okay? Because instead of going like that and thinking this is just a branch and not part of the parent chain, I can go like this. 1, 2, 3, 4, 5, and 6. Even if there's a little bend here in the molecular formula, that does not mean I changed my goal of finding the longest carbon chain. 1, 2, 3, 4, 5, 6. This is not a pentyne. This is a hexyne, okay? So we're just going to go ahead and erase this piece of crap, and we're just going to rewrite that like this. So 100%, I'm just going to get out of your way here. 100% we know that this is going to be hex something or other. And this tells us that there are 6 carbons in the parent chain like that. All right, now is this an alkane, alkene, or an alkyne? Single bond, single bond, single bond, single bond, single bond, single bond, triple bond. A triple bond tells me that this is going to be an ine of some kind. We have a triple bond. Okay, now, which carbon is the triple bond on? Well, we could start from counting over 1, 2, 3, 4, 5, 6. We would encounter the exact same problem that we did in the last example, okay? We want the lowest number possible right over here. We need the lowest number. So, if I count from right to left, this would be on the 1, 2, 3, 4th. We're not going to put hex 4-ine. Okay, that would make no sense. We want to count from the left to right. This would be on the 2nd carbon, hex 2-ine. Okay, first part of the battle done. Okay, so number 1, don't forget you want to find the longest carbon chain. Doesn't matter if there's a bend in the formula. Always try to follow the longest carbon chain, even if there's a bend. Okay. Number 2, you want to make sure you want to have the lowest number possible for the double or triple bond in the ene or ine. In this case, it's an ine, hex 2-ine. Now all we got to do is figure out what are the branches. Okay. So of course we have these 2 branches over here. So we know that we have some branches. YL means we have a branch of some kind. Okay. What kind of branches are these? CH4, 1 carbon. CH4, 1 carbon. We have 1 carbon branches, okay? So this would be a methyl branch. How many of those do we have? Class is a very similar example to the last one, okay? So this would be, we have 1 carbon branch, and we have 2 1 carbon branches. This would be a dimethyl. What does the di tell me? We have 2 of these, 2, and then the meth part right over here, 2 1 carbon branches, 2 1 carbon branches there. Which carbons are they on? Well, if we remember that We need to have the lowest number possible for the triple bond because it's more important than having the lowest number for the branches. We are going to stick with this numbering scheme, and we're going to go like this. It's on the 4th and 5th carbon. So then we would just go like this. This would be 4,5-dimethyl hex 2-ion. An incredibly similar example to the last one, but a few tricks. There's a bend over here, okay? And you have to remember which way to number your carbons so that you have the lowest number for the triple bond there. So class, that is the last example that I have to show you. If you have any more questions, please let me know. And watch the videos because the videos should be able to go over some of the more difficult examples. And yeah, hit me up if you have any more questions. All right, Mr. Lau out. See you later.